on. Here we go. Perfect. All right.
Okay, you can switch on the big screen.
Yeah. Wait 1 second. Oh, we are up. Perfect. Hello everyone. Pleasure to be here. Very glad to have all of you in the room today. This is exciting. Real quick before we dive in, as you might have noticed if you looked at the schedule for today, there was supposed to be a talk by my friend Guillaume later. Unfortunately, he got himself injured over the weekend. Nothing too life-threatening, luckily, but he wasn't able to make it this year. So I do want to say, on behalf of myself, the rest of the Directus team, everybody here presumably, we wish you a speedy recovery. All the best. So what we've done now is we kind of combined our two sessions together. So I was going to introduce sort of the problem spaces that we've been working on. He was going to introduce some of the solutions that we've been working on for those problem spaces. So I merged it all together. So if it feels like this is a little haphazard, rest assured, it is. So let's start with a quick show of hands. So we'll start with an easy one. I'm assuming this is most, but we'll see. Who here is working with some sort of backend API data in their Vue apps? Either a BFF or just... Okay, yeah, that figured. Mostly everybody. So who is using data from multiple APIs at the same time, or multiple endpoints, basically the same crowd, right? So who has done that and had it work sort of the right way from the start? Right, me neither. Well, this is great then, because otherwise I wouldn't be here. So this talk is just for you. So imagine, you're building a Vue app, you're pulling in some data. You might be pulling in product inventory from Shopify. You might pull in some data from a CRM to stitch it all together. You might have some real-time pricing information from a socket API. How do you make sure you keep all of that stuff, all of these different bits of data in sync? How do you do that performantly? How do you keep it reliable? Especially when networks and computers, let's be honest, are super unreliable, right? It's a challenge of data federation, so that's what we're going to be talking about today. I'm Rijk. I'm Dutch-born and raised developer designer. I live in Brooklyn, New York at the moment. I'm the co-founder of Directus, which is a backend platform designed to help you tackle some of these data challenges in your Vue apps. So it's a backend platform. Think about it as basically the best parts of a backend as a service combined with the best parts of a CMS. So we see it used for a wide variety of data use cases, things like all the way from website content management, CRM use cases, or any sort of proprietary data thing in between. It was heavily based on APIs, hence this talk. We have REST APIs, GraphQL, real-time APIs, things like that, and then a data studio that's totally built in Vue and Nuxt, hence we're here, to help sort of the technical and non-technical users work with that data. So while we were building Directus, we've obviously learned tons of things because we've been working with, our own data APIs, external APIs, building a Vue app for a couple of years. And we learned a lot because it turns out this stuff is quite tricky. It's a little difficult to do, really. Loads of edge cases, lots of different types of users, so therefore every design decision that we make, both technically and from a user experience perspective, really has to be made with a lot of care. For example, in our own studio, we end up federating data from a range of different sources. We have a bunch of system API endpoints from our own system for things like permission management or authentication. And we mix that in with data that's provided from the user. So we have a bunch of different databases to connect to, some other sources, third-party APIs. There's then also plugins and extensions that might change that data. Long story short, there's a fair share of front-end data problems that we have to be tackling every day. Just as we did while building this studio, you'll eventually find yourself, and based on the raised hands earlier, this is already the case, you find yourself juggling data just to and from all of these different places, all of these different data sources when building Vue apps. There's quite a lot to take into account when it comes to handling data from all these different sources performantly and reliably, important word. So we're taking this opportunity here today to go over some of the major factors that we ran into while building Directus itself, and then how we've solved that over time. Starting with the easiest of them all, caching. So we've had a great chat earlier today by Eduardo, and I'll mention him a couple of times because there's some really fun stuff happening in this space. But first and foremost, a little bit of caching feels like a super obvious thing, right? It's like, well, yeah, you make it fast, you don't do the calls. Big whoop. It is by far the easiest way to make an app more performant and reliable. But it is also way trickier, right? It's one of the trickiest things. I mean, we like to use analogies a lot at Directus, so I kind of say, caching, it's kind of like a fridge. You put a bunch of stuff in it, you forget it's there. After a while, it starts to smell, right? It's it's messy. It's messy. So when it comes to Vue components and you're fetching a bunch of data, let's start with a super basic, barely working example. You just fetch a bunch of data, show it in a component, life's good. Well, until it super isn't. A couple of immediate flaws and obvious things that we've seen before 100 times again, right? It's what about loading states? What about error handling? Things like that. We could start quickly throwing in more and more boilerplate to make that happen. It's a lot more verbose. It still kind of works, kind of doesn't. Don't do this, not an example of how to do this, right? But as you can tell, as soon as you render this component a couple of different times, or you have multiple components doing the same thing in the same way, you're fetching tons of data over and over and over again. So one easy start to improve that is by moving some of that logic externally and share it between different components. This is basically how stores came to be and how you fetch data modernly now. You make the new async function in some different file, and you use that async function to fetch the data. Therefore, it's always pulling from memory instead of the API, if it already exists. Kind of technically works. It's even somewhat reactive, because if you use the Vue refs for this, then it will trigger updates and things like that. That being said, this will grow very unmaintainable over time. Now, this is really the domain of Pinya, right, at this point. Again, shout out. Throw it in a store, make it easier to use. You get great dev tools. You get way better state management. Makes it a breeze. Big shout out. Big fan. And then from what we saw this morning, Piña Colada makes it even easier by just wrapping it all in a sort of 10-stack-like query abstraction that helps with the querying and the query level caching. So caching is the easy part then, right? Now we're done. Great, love it. It's basic memory query caching and request deduplication out of the way. But there is a bit of an elephant in the room when it comes to query level caching, right? So that is where you make a request, you cache the exact output as is. And that is what happens if two different queries contain the same data. It sort of overlaps like a Venn diagram, right? What happens if that data is used in different places, but it's sort of coming from the same source in the API, but it is two different queries? If, for example, I have a directory of users and I click on one of the users in my app to go to a detail page or a form or something like that, am I now refetching that user from a different query? And how do we keep those two things in sync? So in order to do that a bit more efficiently, you want to end up normalizing some of the cache. And what that means is that rather than caching based on the query itself and the direct output, you normalize the data that comes out of that query in its own sort of data store. So you can then make sure that different queries that access the same data always pull from the same source. And that, again, in that same example that I mentioned, right, if you have a list of people and you click on one, you already have that person, because you already fetched the information for that person as part of the list. So why fetch it again for the detail page? They're two different queries, but you're fetching the same data in a different way. It is definitely a little bit more advanced in that sense, and there's a lot of bottlenecks and additional boilerplate that is involved in doing this. So I'll try to condense it a little bit with some pseudocode to get the idea across. But this is, again, not a sort of functional thing, right? Don't go take screenshots and use this in production, please. So in this brief example here, we're storing the records about the individuals as just a list of people, right? So in this case, just a simple array in this example. But you see we have two different queries. So we have a query to get many people at the same time for sort of a listing overview of like a directory. And then we have a sort of detail page variant of that, like the get one. Simple example, I know. But at the end of the day, as you can see, in the get many, we store it all in that same array. So therefore, when we do a get one, we can pull it from that same array. And that also means that we just normalize that cache now. Right? It results in a better caching performance, because you only fetch the same data entity once. But there's tons more overhead and boilerplate, as you can already see, because this is already growing big and we're only doing one thing. I don't want to spoil the session tomorrow about Nuxt content too much, but I did see that their major upgrade that just recently shipped is doing a similar thing now, where they're pulling the content documents from a database that runs in the browser rather than doing individual lookups to the files. I can only assume it's for very similar performance reasons, right? And it shows in that release. It's been way fast. Big fans again. So with sort of that caching and that normalizing idea out of the way, we're fetching and refetching it from the cache in basically the most optimized way I can think of. However, once you do go the normalized route instead of the query caching route, we create a bit of a new problem, and that is mixing these different sources. So in a query-based cache, you could end up querying a bunch of nested relational data, for example, as part of one query, right? So in the, let's say you're fetching blog posts, you might have some information about each individual author as part of each post. When you're normalizing that cache, ideally you want to store each of those authors separately from the posts. So therefore, if you query an author, you don't have to go, make a new query. That does mean that you have to do a bunch of stuff yourself, right, to make that work. So if we use that previous example as a starting point, once we start dealing with multiple data sets and therefore multiple calls, we have to add new query functions into the mix that will combine all of that normalized data back into the sort of shape that you need it for in your front end. So for example, here, my little pseudocode thing, I threw in an article interface here, and each article has one author, therefore there's some nested relational structure going on, right? In the get articles with author query now, I'm explicitly saying, well, when we're looking at articles, I want to nest all the authors. So my little simple map example here is just pulling what is the author of the article and then nesting it under that article itself when it's being used. I sort of omitted, because there was only so much code on the screen, but you can imagine that within that articles with author function, you do also have to account for, okay, if we're trying to read the articles that don't exist in our normalized cache yet, where did those come from? Or when I have an article with an author that doesn't exist in my normalized cache yet, where does that come from? And when and how do we fetch that? And of course, we still need the other queries for getting the individual people or the list of people separate from this. So again, I just omitted it for brevity, but you can imagine this is already growing quite big. If you're not careful with how this is architected, at this point, the cons of maintenance and growing code base and complexity very quickly outweigh the pros. Keeping all of this code or keeping the code maintained and tested will just get exponentially harder the more and more entities you're trying to manage. Because even in this example, this is just articles and people with 3 different queries. This is already going to be a tremendously large and complicated thing. There are some abstraction libraries that handle some of this normalization, especially in the sort of GraphQL ecosystem. We've seen quite a lot of things pop up in that world, where they normalize the individual sort of resolvers as the data points. Apollo is a great example of an ecosystem that does that. So with the basics of mixing those data sources figured out, it is getting overwhelming, isn't it? If you start normalizing the data, it's a performance improvement, it's great. But now we're making it way complicated for ourselves. But bear with, there's 2 more additions that I want to throw into the mix that we ran into when building directives that are directly related to this whole. First and foremost, real-time updates. So now that we have a cache and we have the stuff locally, what happens if something changes on the back end? Right? Because we're fetching a query, cache first, ideally, because that's the fastest we can possibly make it. Something changes on the API. How do we invalidate that cache? It's the classic joke, everybody here knows it. Cache invalidation, one of the 2 hard things in computer science, right? With naming things and off by 1 errors. So how do we do that? There's various strategies for cache invalidation at this sort of client level. You can invalidate it after a certain amount of time, a couple of seconds if you have stuff with high repeat reads, but frequent updates, you can make the time lower. You could do it more of a least recently used style, where you say, okay, the stuff that is frequently accessed we keep, and then we sort of invalidate it over time. My preferred approach for this, and how we handle it in the studio too, is more event-driven. So whenever something changes on the API, inform the front end somehow, and then when, and only when, something was changed in the back end of it all, do we invalidate the cache on the front end. So in order to do so, you have to listen to events coming from the server somehow, and then refresh the cache. This is going to be super specific based on what tooling you use, right? So for the directives API, the WebSocket spec is very different than from other tools, mostly because there aren't really a lot of standards around what the event formats look like and things like that. So again, this will be a little bit of an abbreviated example for the sake of getting the idea across, but your mileage may vary based on what you're doing for real. So in this little updated example here, Now, connecting to a WebSocket using just a plain old JavaScript WebSocket object with a simple event listener that says, okay, whenever an update message comes in, do a thing, right? It allows us to run a little bit of code whenever the server tells us an update happens. But now the choice becomes, how do we update that cache accordingly? We could just invalidate the whole cache every time, because you know, if you're dealing with relationships, you don't quite know. Something changed, therefore we have to assume the client is out of date, therefore do a new fetch whenever the next call is being made on the client. It works, but you know, you end up replacing the cache so often and invalidate the whole thing. We can do better. We can do a lot better. Ideally, the API that we connect to tells us not only that something updated, but it tells us what the thing is that changed. So if the backend informs us what individual item in what data set has changed, we can invalidate that one individual record from our normalized cache, but keep everything else in place. If the cache is query-based, however, like we saw in the beginning, that becomes a bit trickier, because now you could have, you know, an author of an article in both your article data set as a nested record, or in, you know, your people directory data set, and you have to invalidate them in multiple places. So this is where the normalization really starts to, you know, help out a lot with the real-time event handling. So in a normalized cache, you can invalidate the individual record that has changed. Therefore, the next time a call is being made for that data from whatever query source that is, we can just refresh that one particular data point instead of everything. Even better would be if the API tells us not only what item changed, but what things within that thing changed. So for example, if a person's name gets updated or something, I want to know what person got updated, but also what is the new name. Because that way, instead of invalidating that whole record, we can just update that one little field in our normalized cache. That's the sweet spot. Not easy. Don't try that at home. Then, to make that a bit more complicated, you also want to make sure that whenever an update happens from the server in that fashion, that you re-render the Vue components in the right way, right? If you already use Pinia or refs for maintaining that store, some of that stuff comes out of the box and is taken care of. But it is one of those things you have to test a lot with to make sure that it's handled gracefully. So now that we've worked in some of the real-time event-driven cache invalidation, we're left with one last topic to tackle here. Mutations. Reading data and caching it is one thing, of course, but a real app will change a bunch of data as well. So for that specifically, you know, in the context of directives, we're dealing a lot with forms, so that is, you know, as many a topic. Form handling. There's a lot of state management, not too dissimilar what we saw in the very first caching example. You're going to deal with loading states, dealing with error handling, et cetera, et cetera. In a very bare bones environment, it's already, you know, getting a bit small on the screen. There's just tons of boilerplate available, or required. For forms specifically, you also ideally have a single source of truth of what the V models can point to from the actual inputs, which adds a new layer of complexity, because you cannot necessarily make that reactive object the cache itself, because then you're directly modifying the cache without saving anything. So you have to make some sort of copy out of the cache, make that copy reactive to use it in a form. And then once that form is submitted, you have to both update the cache locally and submit it to whatever data backend you have that it needs to go to. So therefore, whenever another client connects and pulls it from the API, you make sure it's up to date. Once again, an area where you really don't want to handle too many things by hand yourself. If you find yourself building a lot of these types of API handling things within components, please do ask yourself, is this what we want to be doing today? The answer probably isn't. Pina Colada, again, once again, a great, fantastic way to sort of simplify a lot of this, right? We've seen it this morning. I hope you caught that talk. If you didn't, please check out the recording. I could do a whole session just on the perceived performance of form data handling, and I have, actually. It wasn't last year here, but I did do a talk on perceived performance and the user experience of it all in Vue apps. Please do check that out on YouTube. Just search my name, you'll find it. So with all of these pieces in place, we've now greatly improved our data handling strategy. We've made it a hell of a lot worse when it comes to actually building of it, because this is just a tricky topic to fix, right? We've created a lot of new problems in doing all this. The combination of all of these examples, the code that you end up with, very, very verbose. It's hard to maintain, tricky to test. Making sure that it remains reactive when you want it to within Vue and not when it shouldn't be, difficult topic. We did end up in a situation where we just, whoops, pushed a little bomb onto GitHub, and now we re-render the whole app every time anything changes. Not good, not good, don't do that. We'll be the first to admit, this is not the kind of stuff you really want to be doing by hand and rolling yourself. So where do we go from there? Now what? We know what these pain points are. We know what our wish is for sort of the perfect setup in how we handle this sort of local state invalidation and cache handling. But what we've kind of learned in the last 25 minutes or so here is like, is this just needlessly complicated? Did we just waste a bunch of minutes? Did we just waste my life? I'm never getting back? Well, as I highlighted in some of the other examples and that we've seen in talks earlier today, and I'm assuming later and tomorrow as well, there are some great libraries and tools available to help with one or more of these problems. Pina Colada is amazing, Apollo Suite is amazing, the GraphQL space has a lot of great stuff in it. Many more projects are starting to come up as well. That being said, what we found trying to refresh our own app and implementing this sort of production ready is that once you combine these 5 major points together, things still tend to get exponentially complicated. So we were looking at all of these existing solutions and thought, well, what if we just made another one? That's typical. Screw it, we'll do it ourselves. So to tell you a little bit more about that, please welcome Directus' head of engineering, Nux co-creator, my good friend Alexandra, to the stage to tell you a little bit more about where we're going from here.
Okay. Hi everyone. Happy to be back on stage. It's been a while. Don't see you with the light, but guess you are still 1,000, which is scary. Today I'm thrilled to introduce something we have been working on with Guillaume since few months, and it's a new open source library designed specifically for the Vue and Nux ecosystem, and it's called AirStore. AirStore is built to address data management challenge across projects and all size, from small application to large size enterprise system. So basically what Rijk explained all the challenge and problem during 20 minutes. So what is AirStore? So it's a reactive data store built to provide finesse data management for any Vue app. Yeah, I say Vue in French. That's what Evan asked. So some of the key features. We get a normalized reactive cache. At its core, AirStore provides a normalized reactive cache, ensuring that all your components always have up-to-date data, which is the main goal for store, but also collocate queries. So it's allow you to collocate queries directly within the components that need them, keeping your code clean and maintainable, because as mentioned, our goal is large-scale application. Form state management, it's also shipped with a form API to simplify form state management and validation, making it easier than ever to work with dynamic data in your app. Local first and real-time experience, that was our main objective when we were working on that project with Guillaume. Be able to have this local first approach. It's definitely a different experience when you have to deal with an app which is local first, except sometimes on Notion. Adaptable plugin system. We want to be agnostic and be able to configure your storage no matter your sources, the way you want to fetch it, because we all have to deal with some legacy stack and API, unfortunately, and the way where data was structured at that time wasn't really think for the future, let's say it like that. So let's get started. Super simple installation process. For Vue, you install the npm package airstore/Vue. And for Nuxt, npm install airstore/Nuxt. And it's a Nuxt module, obviously. First step, once we got this package installed, when you have to deal with data, there is always this first step, which is define your data model. So to do so, we can create a data model in a single file. In this example, that's a to-do data model. Not very fancy, but a great example to start with, where we can leverage TypeScript to define the type. And you can see this dot model, which injects your model into Airstore. So in one file, you can define multiple models. So you can define your whole database, for example, in one file. And if you have to deal with multiple databases, you create multiple files. Second things, which is super important, as Rijk mentioned, when we have to deal with data, we also have to deal with the validation of it. So for more control of your data model, we can define some default schema validation using the schema property. This is useful for validating data, for create or update operation. So the schema can be defined using any validation library. In this example, we are using Zod, but you can use any kind of library that implements standard schema. And then relation. So any important feature when dealing with data model is relations. So we can use the relation property in the model definition to define the relation between models. The relation property is an object where the keys are the name of the relation and the value are objects that define the relation. You can define one-to-one relation, but also one-to-many relation by setting the many property to true. That was the first step. So we get our data model set up. We get our relation. And because we know we have to deal with the mutation, we define some schema for validation. So by default, Airstore doesn't make any assumption about the way you fetch data in your app. So plugins allow you to extend Airstore by providing your fetching logic. The main use case for plugins is to add support for different data sources, such as REST APIs, GraphQL APIs, local storage, and others. Plugins can also be used to add support for different data formats, such as JSON, XML, or CSV. Here, a quick example about a plugins for your REST API. So to define a plugin, you can use the define plugin helper to get autocompletion and type checking. The plugin is an object with a name and a setup function. The setup function is called when the plugin is registered. It receives a plugin API object that contains a useful method to customize the store. Then, in the setup, you can leverage hooks. Hooks are the primary way to extend the functionality of the store. They allow you to run custom code at different points in the lifecycle of the store. The hooks are called in the order that we are defining it. So in that example, which is super simple, you can see that we are calling our API in their own format, leveraging the payload to pass data, and that plugin is just one connector. So if you get multiple API to deal with, you just need to create such plugin. Like what Rijk mentioned, and our focus was about real time, so obviously this is an example about a plugin with WebSockets. Oh, it was fast. So in this example, you can see better than me. We get a hook for subscribed, unsubscribed, and init. So you can subscribe to channel and topic. Super simple. You will have more example on the documentation and the playground to play with it. So we got the data models. We are connecting them with their sources through plugins. Now it's time to play with that with data queries. So Airstore provides 3 ways of fetching your data. The first one is query composable. So we got 2 composable, query first and query many. By default, it's reactive. That means it's first try to find the value on the cache, and if it doesn't find it, going to fetch it using your plugins. The second one are cache read. So pick first and pick many, which is a way to fetch data only in your cache. And the third one is single query. So find first and find many, which is run only once your query. But also, because we get a way to query data, we need also to find a way to, depending on your data, how you want to fetch this. So we define fetching policies. So first, the query composable as mentioned. We get the query first. You just use useThrow, get your key, and do your query first with some key parameters. Same for query many with those parameters, but you can also do it with fetching relation. As mentioned, we define the relation in our data model, so we can leverage the include keyword to link your relation. Query composable are the recommended way to fetch data from the server. They are designed to be used in Vue components and return a reactive result to be used in your component. Now speaking about policies, we get 2 ways to define your policies for your query, for fetching. One which is globally. When you create your store, you can define the fetch policy, but also when you do your query in your component, you can also specify which policy you want to leverage. There is 5 policies available. Cache first, which means only the cache. Cache and fetch, which is the behavior that the query will first fetch the data from the cache and then the adapter plugin updates the cache. Fetch only, which is the third option, means that the query will only fetch the data from the adapter plugin. The data will be stored in the cache when the query is resolved. Cache only means that the query will only fetch the data from the cache. And the no cache option means that the query will not use the cache and only fetch the data from the adapter. Third one, collocated queries. The main advantage to have a store that is sharing the state of your data is to be able to leverage that querying in multiple components. Which means in this example, if you are using a user in your header because you are logging, you want to display your username, you are doing this query first to your Airstore. And if you want to use it in your profile and an update appears, the centralized cache ensures that the data is up to date also in the user profile component. So no matter where you're doing the change, they are all in sync. So Airstore automatically normalizes the data, ensuring a single source of truth. If a request piece of data isn't yet in the cache, Airstore will fetch it on demand, making sure your app always has access to the latest information. That was data query. Now we get the data, it's time to update them with some mutation. And let's see how mutation works in Airstore. The 3 mutation that we know is create, update, delete. So let's start with create. To create a new record, you can use the create method on the store. Super simple. This method takes an object with the property of the record you want to create. Then we get the update. So to update an existing record, you can use the update method on the store, but you can also use directly the $update method on the record itself as a shortcut. So you don't need to specify the ID. Same for the delete. You can leverage the delete method directly on the store or the $delete on the item. The fun part now, form handling made simple. Forms are a core part of most applications, and we want to make working with them seamless. Airstore includes a built-in form handling abstraction that makes it easy to manage form state, track validation, and respond to real-time events affecting the form data. No more scattered state management, just a straightforward and reactive approach. So we see in the first step how we define the schema in the data models. Now it's time in your component to leverage that schema in a form validation. We have several special properties. We have a $reset, which is a method that resets the form to initial state. We have a $save method, which saves the form and creates a new item. We have also $loading, booleans for indicate whatever the form is being saved, a $error, a $schema for the validation, and a $onSave, which is on the example, which is a method that registers a callback to be called when the form is saved. Speeding up a little bit, I'm starving. So by default, so for the few who knows me and the work we did on Next, DX is a core value, and I try to bring that as much as we can with Guillaume on the directives team. So our expectation was a great DX by default. So since all data returned from Airstore is reactive by default, you don't have to worry about managing state update manually. Your component automatically updates when data changes, providing a smooth developer experience without an unnecessary boilerplate code. And of course, you have seen it on some example, but full TypeScript support is included out of the box, providing auto-completion and type safety to supercharge your development. Obviously, I couldn't build a solution without having a built-in Nuxt support. So for Nuxters, we have created a Nuxt module that will automatically scan the Airstore folder in your Nuxt app for models, scan the Airstore/plugin folder and register plugin, create the store, handle SSR payloads, expose the useStore composable type accordingly to the model, and the big one, we have the Nuxt DevTool integration by default, allowing you to inspect the cache state, monitor data mutation, and debug query seamlessly. Last but not least, open source. So today we are super exciting to officially launch Airstore as a standalone open source project. And it's ready to use now. It's available right now on GitHub. We would love to have your feedback on that. Give it a try and help us shape the future of Airstore by creating your own plugin. Big shout out to Guillaume, who couldn't be here, and the huge work he did, especially last night with me. And thank you all for your time. I can't wait to see what you are going to build with Airstore, and now it's time to Rijk to be back.